Yeah, I thought it might be good to talk a little bit about the next release of OpenZFS that we're putting out. So this is going to be a little bit of a different talk, maybe than what we've had so far, since it's looking at what we did over the last year rather than what we want to do. But I thought it'd be interesting to put it together and give everybody an update. So we were just talking in the parking lot about how much current activity and churn there is in the OpenZFS tree. So not everybody probably knows what happened in the last month and got integrated. So it was kind of interesting to go back and review what's been done and what's interesting. So this won't be an exhaustive list of changes that were made, but I tried to pick out the most interesting stuff or the most noteworthy, or maybe whatever just struck my fancy at the time. So where are we in the release cycle at the moment? So for OpenZFS, we put out major releases about we shoot for every year. It ends up being more like every year and a half, something like that in practice. So we're coming up on putting out the 2.3 release now. So where are we at in that process? About 2 weeks ago, 3 weeks ago, I don't know, something like that, maybe a month ago, I cut the official release branch for 2.3. So that means we're feature complete at this point. There won't be any more major additions to the branch. Any new features are eligible to be merged to master, but we won't be picking any more really big disruptive changes into the release branch. As part of that, we've got the usual process of doing things like bumping the library version. For those who aren't familiar, part of the process we go through here is within a major release branch, right, we have a stable ABI that we check. So within the 2.2 series, right, libzfs, those interfaces won't change. But we do allow them to change in the master branch while we get ready for the next major release. So when the 2.3 branch gets cut, which it just did, we bump the library versions. I think this might have caught a couple people off guard, actually, when it happened this time. But that's typically when we do it. So now we've established a new stable library versions for libzfs. Those will be stable for the length of the 2.3 release, which is, at least for typically 2 years, we'll maintain the 2.3 release. I guess one other thing folks might not know about those release versions is the way that we've always structured the RPMs, at least for the last couple of releases, and you can install multiple versions of those APIs concurrently, right? So you should be able to install the headers for like version 5 libzfs 5 and libzfs 6 concurrently on the system. So those have been stabilized now. So at this point, we're just trying to wrap up any remaining issues in the release branch before tagging a major release. We have some known issues we need to work through still. We're working on it. We will integrate those into a couple more release candidates before the final tag. And then the usual bits involved in putting together a release, right? We've got some packaging updates we need to test out, documentation, and then here's my call for testing for everybody, right? So we've got 2 release candidates under our belt so far. So there's a 2.3 RC2 available now for folks to download and start kicking the tires. A lot of good issues have come out of that we fixed. We're right now staging a new PR for RC3. The link is here. You can find it in GitHub, right? But here's where I've been accumulating backports from the master branch for additional fixes to pull into a 2.3 RC3. Hopefully we won't have too many more RCs, and then we'll put out our final 2.3 release. So I think that's a pretty standard process, but that's where we're in the cycle at the moment. So like I mentioned earlier, typically we shoot to put out a release every 12 months. In practice, that doesn't often happen. Usually it's more like 15 months to 18 months, right? So we're about 15 months for the 2.3 release cycle. Activity looked about the same to me compared to prior releases. We had about 900 commits between the 2.2 release and the 2.3 release, which was about what we usually see, and over 100 contributors, which was great. So thank you to everybody for this release cycle who contributed stuff. It's great to see the continued contributions from folks. And with that, what I wanted to do was probably go through some of the major features and interesting features that we've integrated over the last, 15 months or so. So I'm not going to do a deep dive on all of these features. It's going to be kind of a whirlwind tour of what went in. But there are, talks at previous development summits talking about all of these things, or at least most of them. So I'd refer you back to them if you really want to know the details. So with that, let's see where we're at. So first one, all right, this one was merged almost right after 2.2 was tagged, and it's been soaking in the tree for almost a year now. So this is the RaidZ Expansion work. This turned out, I would say, really well, and we've had some good reports that everything's working well with it. It's had a lot of testing, so it's in good shape. This is probably one of our most widely requested features, so I'm really happy to see it finally get integrated. And it has been under development for a long time, I think, as everybody here knows, right? This was a long time coming and a big lift, but I think everybody will be happy to see it finally be here. So just to refresh your memories, right, some of the high-level design details for RaidZ Expansion, right? It works with RaidZ 1, 2, and 3. It does not work with DRaid yet. There were provisions put in DRaid originally when it was merged, but none of that's been implemented yet. So you can't use RaidZ Expansion for a DRaid pool, but that would be a cool thing to look at in the future. You can expand a pool multiple times, right? These are all things that have been talked about in the past, right? Reflow data retains its previous data to parity ratio. Pre-expansion, and then post-expansion too, the ratio doesn't change. When you add another drive, you get the new data to parity ratio. So that can complicate things like free space reporting a little bit, which I've heard we've had some reports of. But that's working as intended, right? One thing you don't get with RaidZ Expansion, though, is you can't change the parity level. I've seen this come up in a bunch of discussion threads too about people wanting this functionality, but that's a lot harder, and that's not something that's supported as part of the RaidZ Expansion. So RaidZ Expansion is in 2.3. Another huge addition that was merged in the last, 6 months, something like that, that Clara and IX Systems worked on a ton. And this was another big lift, was improving dedupe, right? So the fast dedupe feature has now been merged. This was a nice overhaul of the deduplication system in OpenZFS, right? It's designed to coexist with the previous implementation, and really from 50,000 feet, like what it ended up being, was a major collection of performance improvements to the existing implementation, right? Looking at a lot of areas where the current dedupe system fell a little bit short and needed some improvements. So I think Alan gave a talk, I think it was last year, about the improvements in this. So I refer you back to that for the details. But the gist is, it tried to address all the shortcomings we had seen, right? So make sure your dedupe table fits in RAM where possible, right? So things are quick to look up, or a dedicated flash device failing that. Move it to a log structured format, right? So we can do efficient updates rather than doing tons of read, modify, writes to the dedupe table. The pruning functionality was mentioned earlier, right? So you're able to prune entries for the dedupe table, just a whole collection of general improvements here for deduplication. So actually one of the other interesting things that I thought that came out of this too was just not the dedupe functionality, but the ability to add a generic prefetch command to ZFS, which I'd like to see. So the only thing that makes use of that now, there's now a zpool prefetch you can issue. And right now you can only let you prefetch the DDT, but it's something we could build on long term if you want to start being able to pull in other functionality. So you want to prefetch a file or the metadata for a file or metaslabs, right? It provides an interface for us to build on where we can pull in perhaps more information if the user knows they need it. So DirectIO is probably the other really big feature that finally got merged. So this is another one that's been under development for years and years and years. I think since at least 2018, it's been being worked on. So DirectIO addresses a lot of the issues that we've seen and probably came up before in talks earlier today about NVMe devices. So for those, we've got a developer group here, but for those not familiar, ODirect basically lets you bypass the cache is the general mechanism. So for ZFS, that means we bypass the ARC for reads and writes whenever possible. It works just like normal ODirect. You pass the ODirect flag to open, and you've got the usual constraints. So I/O needs to be page aligned to be issued down the stack. Otherwise, it fails with an error saying you have to page align your I/O. ODirect's desirable for a variety of use cases, right? Again, some of them were mentioned earlier, like databases in particular often implement their own caching mechanisms. It makes sense to bypass the cache in that case for direct I/O, or cases where the data is only read once or read or written once, and there's no point in actually caching it in the arc, right? In those cases, it may make sense to bypass the cache as well. Or, in particular, for really low latency devices, like we heard earlier, where just manipulating the data and processing it can add significant latencies to the I/O times. So being able to bypass the arc can be a significant win there. One of the things that motivated us to do this originally was that we found that for when you have lots of NVMe devices in a pool and they're high performing, just the copies in and out of the arc can limit performance. So just the copies alone limit things. So the way that this works, right, is with the direct I/O patches in ZFS, the user pages get directly mapped into the kernel, and then we do as much I/O as possible directly with those user pages. So they get mapped right down into the I/O pipeline, and we do I/O on that to avoid copies. Obviously, there's some cases where you can't avoid copies, right? So if you have to do any kind of compression or encryption or the calculation of the parity blocks, right, you're going to have to for compression and encryption in particular, right, you have to copy the data because you're manipulating it. And then, for RaidZ parity columns, right, we have had to read the data and calculate the parity. So there's cost there. But the idea is to touch the data as little as possible. The data is still checksummed, right? So you still keep all of those guarantees. So we do have to process it or touch all those pages to calculate the checksums, but it's kept to a minimum. One of the other design decisions we made long ago with direct I/O, which complicated things significantly in our implementation, right, was that we always wanted to be coherent between if you mixed buffered I/O and direct I/O. A lot of file systems don't work this way, and if you're mixing and matching buffered I/O and direct I/O, you won't necessarily see a coherent view of the file. You'll end up bypassing the buffer cache. For ZFS, we wanted that to always be coherent. So even if you're doing crazy stuff that no application should reasonably do, right, and mixing your buffered and your direct I/O, you should get a coherent view of the file. So that means sometimes we have to invalidate pages that are in the arc, right, or we have to pull pages into the arc if they use that interface instead, just to make sure that we get a coherent view of the file. And one other thing that was added here is a new extension to the zpool status command, where you can see not just errors that are introduced. Let me go back. So like I mentioned before, we're operating directly on the user pages, which means that the users have access to those pages. They can modify them, right? We're not copying the data directly into the arc. And we want to be able to tell the difference between if the user modified a page, and that's why the checksum fails on it, or there's another issue there. And we want to report those independently of checksum errors in the pool. So there's a new column that was added to show data verification errors that indicate you gave a buffer to direct I/O and it changed before it actually hit disk, right? The user did something to it. The checksum's not wrong. Well, it is wrong, but it's because the buffer changed. And that was actually very, very interesting because we found a bunch of cases with badly behaving software that tend to do that, it turns out, right? And it was causing checksum errors in the ZFS code because it was detecting that the user code was manipulating the buffer when it shouldn't, right? So those are now detected. Code has been added to ZFS to find that, and if it does detect that you're messing with the buffers, it will typically fall back to reading or writing through the arc, right? To give you a coherent block written to disk, so when you come back and read it later, the checksums are good. So that was a big lift. That was recently integrated for the 2.3 release. So those were the three, probably the big major features that went into 2.3 that I think people have seen before and people are aware of. But in addition to that, we had a ton of nice to have stuff that just went in with maybe a little less hoopla associated with it. JSON output for most common commands. Yes. so maybe this is actually more desired than RaidZ Expansion. Because this is certainly a long time in coming, right? And in fact, I forgot about it myself and forgot to add it to the initial draft of the release notes, right? But this is a big one, right? So JSON's been added to probably the most common commands now in ZFS. So things like z-pool status, z-pool list, z-pool get, those commands all now take a JSON flag and give you structured JSON out for them. I think personally there's a lot of opportunity to expand this, right? We didn't enable every command, but you can imagine having z-pool iostat or z-pool history give you kind of more structured output in JSON for those commands. So we can get away from like scraping the CLI output, which I'm sure everyone hates that. Yeah. That's so some interesting discussions did come out of that. You'll also see there's a couple flags that went in with the JSON output. I guess it depends on your libraries and how they interpret JSON, but some of them interpret integers and strings in the JSON output, and depending on the libraries you're using to parse it, they may interpret it differently. So there's an option there to provide output either as integers that aren't quoted or like have all the integers be quoted in the JSON output so they appear as strings. There's a flag for that. There are also some use cases where there's like an alternate format where it'll collapse the hierarchy of VDEVs into like more of a list rather than a hierarchy, because it just makes it easier to iterate over the JSON if you don't have a hierarchy there. Again, optional flag, but nice to have stuff. I'm hopeful, like I say, we can build on this as people start using it and finding spots where it either needs to be extended or new commands need to be enabled. But yeah, this will be nice to have. Another nice to have that was recently merged too was long file name and directory support. So this is something that's maybe not as useful if you're using the file system directly like on Linux or FreeBSD, but if you're using it through something like a Samba share, right, or you're embedding Unicode characters or those kind of things, you actually run up against that. The previous limit was 256 characters. You could actually run into that quicker than you'd expect, depending on your file names. So that's now been extended to almost a kilobyte, right? And this is controlled with a long data set property that's been attached to all the data sets. By default, it's disabled, but you can enable it as needed. If this is a use case you have or you're using it for like an NFS or Samba filer, you can turn it on. For the moment, it's a Linux-only feature, not because ZFS is limited in this way, but apparently we ran into some issues in the FreeBSD VFS layer that imposed some limits. Those can be worked on and improved, I'm sure, but at the moment, you can only get the long-range file names with Linux. So we have some more nice-to-have features, right? So .zfs snapshot directories we were talking about earlier, right? Historically, this has been controlled by the snapdir property for snapshots in particular under there, right? And it can be set to either visible or hidden, and it would prevent traversal into the snapshot directory if it was hidden, not because you couldn't traverse in there, but just because it wasn't reported in the directory or dirents list, right? Or it can be visible and you can see it. Well, there are cases where it probably makes sense to actually be able to disable it entirely, and this wasn't possible. So like say you've got a snapshot that you really don't want to be accessible anymore because it was taken at an unfortunate moment in time, right? So turn it off. So you won't be able to traverse into any of those snapshots until you fix it up or delete it, right? So it's a nice additional administrative control that's finally there now. So this was added just as another option to the snapdir property, and that was possible because of some additional work that was done in 2.2 to let us like properly be able to extend existing dataset properties with new values. So that was a nice bit of work to dovetail on that. Additionally, I don't know how many people use redaction snapshots, right? But there was previously a limit there of 36 redaction snapshots. Paul did some work there to allow those to spill into a spill block, so we can do more of those now. I don't know exactly what the new limit is, but I imagine it's quite large. Yeah, it sounds about right. I mean, you had hundreds of bytes, and now you have kilobytes, so right? Yeah. So anyway, large enough you shouldn't hit it. Other nice to have things, parallel pool import and export, right? I guess that's a popular one too. So not so important if you've only got one pool on a system, but if you have a lot of pools on your system, then they were previously serialized, right? And they had no particular reason to be, right? They could be done in parallel. And now they are. So zpool import-a and export-a will fully parallelize the pool import and export. So if you've got a lot of pools, it should speed up, startup and shutdown times if those are your use cases. Even more nice to have features, right? So there's been a lot of these items that people have been working on that maybe haven't gotten quite as much visibility. And some of these, I should add, I think on this list too, may have been backported to the 2.2 release too. They went into the master code, but they were nice to have things. They didn't break any of the library APIs or change them in ways, so we were able to backport them cleanly. So the first one here is one of my favorites, personally. It seems like a little thing, but on the systems I work on, they're typically DRAID pools and they have hundreds of devices. And when you run zpool status, 100 devices is too many to see the output when you're looking for something that goes wrong, right? So you can use zpool status-e and it will show you any VDEVs and only those VDEVs and their parents, right, that are unhealthy, right? So you can see, like, okay, this one's, and by unhealthy here, we mean like something not in an online state, right? It's been removed, it's been faulted, there's read share errors, there's write errors, checksum errors. There's something wrong with the VDEV that you should really look at, right? And this has been particularly nice for our setups because we have a lot of pools over a lot of nodes, they have a lot of disks, and being able to eyeball them in a reasonable way has been very helpful. So I know this one was backported and I use it a lot. Another nice feature for those of you who have enclosures where you can like independently power cycle the slots on the enclosure side, the zpool commands were updated. Zpool online and offline now take a power flag. So you can not just power cycle the disk in the slot, right? But you can actually power cycle the slot directly of the enclosure. As long as your enclosure supports the SES driver, right? So it's been written for Linux and it relies on the generic SES driver in Linux. Could be expanded for FreeBSD if someone wants to do that work. Like all the hooks are there, they're just disabled at the moment. I'm not quite, I would assume FreeBSD has an equivalent of this. It just needs to be wired up. But this is a nice improvement too because often we've seen drives that act up and you just want to, you just want to power off the drive, right? And get it off the bus. Along with that, we've had a bunch of improvements Don's been working on and a few other people for the Z, which have been really nice. Like part of this work, again, was powering off the enclosures slots when faulting a disk. This kind of dovetails again with the zpool online offline work for the slots, right? Often we'll have a drive act up and you just want to power it off. And in fact, we want that to be the default behavior for any drive that acts up in the system. So we've configured our systems this way now. So when you fault the drive, it gets faulted and then the slot just gets turned off. So it can't act up anymore. Depending on your enclosure, you may have to turn it back on, but we found with a lot of modern enclosures at least, like when you put a new drive back in the slot, it'll automatically power it back up. So typically this is very nice for maintenance. It just turns off the slot, takes out of action, and you put a new drive in, it spins it up, adds kicks off the replacement automatically. That's great. Slow disk I/O diagnosis. This has been improved considerably, so we get slow I/Os and can act on those. I personally think there's a lot of good work to be done here still, right? We track a lot of information about the individual drives and could do a better job of identifying particular drives, like in a similar population of drives, this one's behaving different than the others, right? So it's just slower for whatever reason. It's not reporting errors. It's just slower. And you might want to log slow I/O errors for that and fault it. That's something to look at longer term. This change doesn't exactly do that, but it does put in place some of the groundwork for allowing that kind of thing and better reporting really slow drive behavior. And here, really slow means like I haven't serviced an I/O in 30 seconds, right? I submitted it down and it's just gone out to lunch. Additional changes to like consider disk peers when you're faulting a drive to determine if like really is that drive the problem or is it something all on the same bus, right? And not take any action if it's clearly not this individual drive that's causing the problem, but something more systemic. And then with the PreviDev zaps, right? Now we can do things, and this code was backported too, for like individual read, write, and check some error thresholds for faulting in the Z. And you can set those at the leaf level or the top level leaf. These are all really nice improvements, I think, to the management functionality that we keep building out, and it keeps getting better. And I think there's still room for improvement, but it's gotten pretty nice at this point. On the developer front, we've had a bunch of quality life improvements. Rob Norris, in particular, should be credited for like a ton of this work. He has spent a huge amount of time clearly improving things for all of us developer folk, right? In particular, the user space debugging, there's been some cool new improvements, right? Just in what gets reported when you hit an assertion or in one of the tools, right? So things like thread names are now visible in the process. The stack dumps now include like better back traces, and very recently it'll dump the registers too for the stack. So when something happens, you have enough information to actually go dig into it and see what went wrong. Little things like the asserts were not serialized before. So if you hit 2 asserts in different threads, they get all mangled together and you couldn't tell what happened, right? So a nice set of quality of life, like I say, improvements for these things. Better task queue stats were part of that too. Previously, we did have K-stats for the task queues, but in practice, they weren't very useful. Now you've got much more visibility into like all of the task queues, which ZFS is using internally. There's an entry, a K-stat entry for each of them, and some high-level stats and some aggregate stats for its behavior, and a high-level summary of like most of the unique, or most interesting, I should say, task queues in the system. So this has been really helpful just to get an idea of what's going on and just surface more visibility. Related to this, I'd personally love to see some more visibility into the pipeline for ZFS, right? And you could imagine doing something similar with K-stat entries for that, so you could see a better what's going on in there. We've also dropped support in 2.3 for really ancient kernels. So I know people who have submitted patches have struggled with this for a while. Like we've always supported back to basically the last supported RHEL release is where we've kind of arbitrarily drawn the line. And that meant some really ancient kernels needed to have support. So if you're submitting a patch, often you'd have to go add compatibility code for a kernel that was, 3 years old, 4 years old, right? Who's running this thing still? But we do have a lot of sites that run the old enterprise distributions, and they tend to ship with old kernels, so it was important. The good news here is we were based on a minimum requirement of RHEL 7, which has now been end of life, so yay. So we were able to move the minimum kernel version here forward to what's in RHEL 8, which is 4.18, a 4.18 kernel basically, a heavily patched 4.18 kernel, which doesn't resemble a 4.18 kernel in practice too much, but it's based on 4.18 in reality, right? And the upside of that was we got to shed a ton of compatibility code that was just a burden to maintain, right? So as part of that, we also bumped the FreeBSD release version too. To anything older than the FreeBSD 13, we shed that code too. So that was a nice win in terms of simplifying the code base and not having to go back and figure out how something worked in a kernel from 6 years ago or whatever. And this was kind of a nice thing too, right? For those of us who try to build it against bleeding edge kernels, right? We've for a long time now had a minimum and a maximum supported kernel version in the meta file in the top level ZFS directory to control like which kernels we build against and we actually try to build against. Just because we want to make sure that you're testing against a kernel that we've tried, we think it's supported, it works, it passes all the tests. But we've always got people who, a new kernel comes out and that day they're like, I want to run ZFS against the kernel that came out yesterday, right? And we have not had time to go through and update and vet it and make sure everything's working correctly. But now, it will still fail the build by default, but there's a nice configure option you can specify that says, yes, I want to do it anyway, and it will appropriately give you a warning that what you're doing is dangerous, and maybe you shouldn't do it, and it will annotate the logs that you're running with experimental support, but it'll at least try the build, and you can do it if you really want to. So here's one, again, a developer-focused thing that I'm pretty excited about. So if you've opened PRs in the last I don't know, 2-3 months, something like that, we'll probably see that we've actually cut our CI over to fully being GitHub Actions based. So since almost the beginning of the project, we've used software called BuildBot to drive the builds for ZFS because it was easy for us to spin up VMs for different distributions and test on them. And because we needed some functionality that you couldn't get from a bunch of other CI systems, we had to be able to load kernel modules. We needed like full VMs to be able to do that. And that was hard to get in other environments. But Tino's recently done a huge bit of work to actually get us fully transitioned over to running our CI under GitHub Actions. And it works pretty well, in particular because it's doing something that you wouldn't think would work very well, but it actually works really well in practice, which is we spin up Ubuntu VMs under GitHub Actions, and then in those, we launch QEMU, and then run multiple sessions of that to do the build and the test, all right? So we're running QEMU under the GitHub Actions VMs for various distributions, and then spinning up a bunch of them so you can run the test suite in parallel, and then pulling together the results at the end to give you, quicker runs in the CI and, parallelize running all the tests. So that's actually worked out really well. And one of the things I personally like about it a lot is it used to be that all of the CI machinery was stuck in BuildBot. It was hard for anybody else to maintain and work on. All of this stuff now is just, config files in the .github directory in the repo. So anybody who wants to, help improve the CI or work on it, it's all available there. You can modify it, you can extend it. We were talking about Z-test earlier and how we'd want to maybe improve it. It's all there, right? How it runs, how it can be configured. So I think this is a great recent addition. It's included in the 2.3 release, but it's more infrastructure. One of the other nice things about it too, right? You can see we've actually got FreeBSD. I'm not sure if you can see that or not, but FreeBSD is in the list there too, which is being run under QEMU on an Ubuntu builder. So lastly, what I've got is things that have been maybe on the roadmap for a long time for things that we might be able to get in the next OpenZFS release, whether that be 2.4 or 3.0. Again, it's not an exhaustive list. We've got lots of interesting things people have been working on. But I know these are things that have been of interest to people for a long time. So the first one here I find kind of amusing because it's like the issue number is after it there in parentheses. This is issue 8 on the tracker, right? We're at like 16,000 now or something like that, right? So way back when, in the first 10, right, was to get a full Fuse implementation going that we could run in user space. I still think that would be really interesting, and I'd love to see that happen. We keep getting closer and closer to it as we improve the user space support in ZFS, but we haven't quite fully integrated a full independent implementation that all runs entirely in user space as Fuse. We laid the groundwork for a lot of that when we did the work for FreeBSD and Linux and splitting it up. You could imagine another supported platform there being just Fuse and a full user space build. Another thing people have wanted for a long time, force pool exports, right? There's a PR open for this. A ton of good work was done on it. It just quite hasn't been wrapped up yet. I'd love to see this in a new future release too. Again, with a lot of these things, it's just, it gets complicated. Like the last little bit, you can get it basically working, and then you're like so close, but there's a little bit more to do to make it actually reliable and solid. Like we were talking about before about making sure all the tests in the CI run reliably and people get good feedback. I think, making sure the tests run reliably and it works as expected is, that last little bit can be a big lift, right? There's another PR open for SHA-20 poly encryption, right? This could be used for low-end systems. There's some good work out of LANL also going on for like the ability to like offload the checksums, compressions to like a hardware accelerator, right? So that's additional work that's underway. I would love to see get wrapped up. Another one on my personal list of things I would like to finally see integrated is support for FiMap. I'm not sure if people are familiar with it on the Linux side, but it's just a better way to report like file layouts for things like copy. would take advantage of it so they know which parts of a file are allocated and which ones aren't, so it can just copy the relevant bits. This is another one where we just need to probably rebase it and think through it hard and address any remaining loose ends. But it's been outstanding for a while. And like we've talked about in the past, I think it'd be great to pull in Mac OS support as another supported platform to the code base at some point. Jorgen's done a ton of work on that. It's in pretty good shape. We just have to, integrate all of that code into the repository. And now that we move to GitHub Actions, it actually gets easier to set up a builder to test it and verify it. So there's some infrastructure work there that maybe we're in a better shape to actually, make sure it works properly. So with that, that's all I had. But I'm happy to take questions about any of those features or any features that I overlooked that people are interested in, or just questions. Yeah.
One of the features you mentioned was the Accelerator stuff.
Yeah.
I remember there was a talk about that at the OpenZFS Developer Summit a while ago. One question that I remember was asked at the time that I'm not sure if we have an update on is the hardware accelerator available? Is that a commercial product, or was that some custom board they made?
So I don't know in particular. I know that there are accelerators available. I don't know if that particular one is generically available. But this is the kind of thing that you could imagine, with their accelerator, or maybe even conceivably being able to offload it to a GPU or something like that, right?
So in theory, you can plug in an Intel QAT, which is generally available. The one we used was from Identicom. It might be generally available. So.
Plug and play.
Curious about the pool export, the forced pool export.
Yeah.
If you export a pool and it doesn't export because you got open file handles and you fail over, you got to have guards so you don't fail back, because if you do kind of reappear the devices or whatever, all that I/O is going to end up flushing through. Does this kind of clean that up so you kind of are clearing all the I/O out, so you kind of don't have to worry about stale I/O sort of hitting the pool after sort of the world has changed?
Yeah. That's basically the idea, is for a forced pool export, you're forcibly canceling anything in flight and throwing it on the floor.
Nice.
So so you shouldn't have to worry about that, right? It should get all canceled. And that's hard on Linux. It really doesn't want you to throw it away. It really, holds references and everything, and it's hard to tear those down. And that's been a big struggle, letting it do that, right? But the idea is, when you do a forced pool export, the understanding is that you're willing to throw away anything that's in flight at the moment and just tear down the pool, unmount it cleanly, because right now the only other option is reboot the node, which is terrible if you have multiple pools on that node and only one is suspended.
Yes.
Right?
Yeah.
Yeah. This is one I know at Livermore we'd make a ton of use of too, because when bad things happen, we don't want to reboot the node if we don't have to.
Yeah. Fantastic.
That's one of ours.
All right.
Yeah.
Cool. Yeah. So we should talk more about finishing.
Future question, I guess. Maybe to add to the thought queue, I tend to be more of a disk person in my experience, and so I think something that would be really cool as I'm thinking through this and looking at all these just freaking amazing features that are coming up right now. There's one thing, there's an image I have in my mind, because it's something I deal with on a regular basis, is you have disks that have typical, disks have their life cycle. They all have different, they all have, depending on the type of disk, they have certain uptime, certain power on hours. We all know what it is, 45,000, 50,000 hours. We all know what it is. And they all have a certain number of PHY interfaces in the back that connect. And so you see a lot of these errors and stuff. And so, yes, I know there's a bunch of stuff for IO stats and everything else, but it would be really cool if there's a way to kind of integrate something sort of like Oracle's FMADM, where you have like a view to just say, in this pool, I have these disks, and just use standard SCSI SG commands to pull out the uptime, to pull out, the number of, the number of PHY interfaces that are available. Because if it's less than XYZ, then you can look at a table. If it's less than that, then that drive needs to be reseated. Maybe the number of SCSI errors or whatever that you might see, something like that could be integrated into the file system would level set the playing field and make something that a lot of vendors try to proprietarize, something that could be more open. So That's my thought.
Predictive analytics.
Exactly, yeah, what he said.
So I agree. That would be very good stuff to have. What we have today, and has been there for a while actually, like the zpool status command, let you can add arbitrary scripts to be executed with it and show additional columns. So you can see things like power on hours, temperature from the drive, smart status, and whatnot. You can get additional columns for that, but the zpool status command. But
What I was thinking about, my thought was to add on, was to take everything that you just said, it's already there, but add it to the dash D command.
oh, sure.
Just put a dash AI
Just show me what I want to see.
Yeah, I mean, because you only want to know the ones that are having the error status. These are some of the possibilities that could be causing problems. So that's less development and just adding a flag. So just throw it out.
Yeah. No, that's a good idea, where you could include additional information where you know there's something not quite right with this drive, just to surface it so you can see it.
Yeah, because this particular pool is either having some latency or it's in a degraded status or it's not being IOs on its side, and here's some additional stats in the verbose mode to say these are some possibilities.
Yeah. The tricky bit there usually is deciding what's bad and what's not, right? You're like, oh, you remapped 2 sectors. Okay, that's not great, but it's not the end of the world, right? So, yeah. Yeah, good ideas.
There's a remote question that's hopefully in context. What happens when the compression isn't one-to-one identical to the deflate in OpenZFS?
If you're...
I'm guessing this is related to the offloader, yeah.
Go ahead, Alan. What was it?
I'm not sure.
So we already did that. Cool. So we already have that. The accelerator we tested with does not write exactly the same data out as software compression, but it's fine. All the checksums are correct. It reads back just fine.
One caveat with somebody that wants to accelerate ZFS, it's like it does need to be compatible in the sense of the accelerator goes away, we still need to get the data back from ZFS. So that really would be on them to make sure that happens.
I know one of the things we're looking at for the accelerator too, is right, to always have a fallback software option for that kind of thing. So like even if you didn't have the accelerator, right, it was written in a format that you could get it back with a less performant software solution. Preferably the existing one.
It's not a different compression algorithm. It's not offloaded gzip, say. It's actually labeled as just normal gzip.
Is there a way to test like these accelerators in the CI? Is like there's there isn't.
So normally when you do this, we have a fallback testing accelerator that just links directly back into ZFS for functionality, but obviously you wouldn't normally do this.
Can you talk a little bit more about the FiMap and sort of what that brings?
Yeah, so FiMap has been my personal wish list for a long time now, right? So this is the interface that Linux provides. I don't know if FreeBSD has something similar. But basically, it's an interface you can request of a file, and it'll show you like what the extents are on a file, where they're mapped on disk, right? If they're compressed or not. There was talk about adding like encryption flags for it, so you could actually see like, okay, here's a file. How is it actually laid out on disk? And it's useful for tools like copy mainly, right? So it'll only copy the relevant bits of the file, right, where there's actually data. And it's just generally useful for inspection of files. Right? There's tools on Linux to dump like what the mapping looks like. You can see how it's allocated. Particularly useful for network file systems, right, where you don't want to be sending a bunch of zeros back and forth. There's been some improvements on the server side with sendfile and stuff like that to improve performance there, but like just having a generic FiMap implementation would help NFS in particular. Right? It would take a little bit of work still to wire that up to things like NFS or like Lustre, if you're running Lustre on top of ZFS.
Yeah.
You need to wire, first you need to have the implementation in ZFS to get that data, right, that's reliable, and then those other file systems need to layer on top of it to expose it.
It sounds like it could be helpful with ransomware detection as well, because you'd see like a lot of change and be able to see it in sort of like a like just a extent list instead of having to like reread the data. You can kind of like see how has it been changed.
Yeah. All right. Well, if that's it.